Let's get started here with lesson 8A. We're going to do our examples using your booklets. So let's look at the first one. We know what a point is based on the definition. If I remember correctly, it's an exact location in space. So we have to, one, know how to name points. That was one thing. A lot of this is how to name things, and that was not covered in your booklets you made. So, do you see any points you'd like to name for us, Dante?
T.
Point T. Very good. I think the easiest way to name a point is exactly that. You put the letter that represents that point. So it would just be one letter. Scott?
S.
S. And another point? Gabby?
U.
U. Now you guys picked three of them that were not connected to any line. Is Q still a point?
Mm-hmm.
Yeah. Is P still a point? Is R still a point? Absolutely. It's a location. So we could have picked any of those six as a point. So number two, name two lines. Again, if you follow in your booklet, line is a straight path that extends forever in both directions. So how would you name one line? How would you name a line? All right, we're already out of new volunteers. Come on. New volunteers. Andrew, name a line. Okay. And? Good. You have to have 2 points to name a line. P and? No. P and R do not connect. What 2 points connect? Andrew? Very good. All right, so Andrew says P and Q. And don't our attention, I should say, doesn't our attention immediately go right here? But when we say line PQ, now this is what hits our attention. The straight, I should say, the straight path that extends forever in both directions. So when I name a line, I use the letters. I also use the line symbol. And if you remember last week when we looked at circles, we used a segment symbol. Okay? A segment symbol is just a bar over it. A line symbol would have a bar over it with what on both ends?
Arrows.
Arrows. And if I'm going to name a line, that's what it has to look like. Line PQ. Okay? There's one more line up there. It's different. Alex? RQ. Very good. Alex said RQ. Was anybody thinking QR? Because my question would be, is there a difference between RQ and QR?
No.
Okay, here is R to Q and here is Q to R. And we're talking about the same line, no matter which way we write it. Okay? All right, so number three, name a plane. This one I need your help with. What's a plane? I think this is what, page 3 in your booklet? I'm pretty sure most of our examples go right in line, right by page. Gabby, what's a plane?
A flat surface that
Extends forever. Okay, a flat surface that extends forever. A lot of people drew like a four-sided figure that maybe was a square or maybe it was looking like a parallelogram. Here's what I want you to picture for a plane. This desk is flat, is it not?
It's not flat.
Is it not flat at the top?
Well, right here.
Is it flat?
Yes.
Overall, is it flat?
Yes.
Sure. So if it extends forever, is this desk going to hit your desk?
No. Or here.
Absolutely. Well, let me move this chair for a second. If this desk extends forever, watch. Oh yeah, they're the same height. That's the same plane. Every desk in the room, every student desk is on the same plane. It's a flat surface that extends forever. Here would be the difference. I lifted it up, and now is it on the same plane? No. Now, if this desk went on forever and your desk went on forever, they wouldn't meet. They would be what? What would they be, Dante? They'd be parallel planes. So think of a desk as a plane if it goes on forever. It's just extending in all directions. Think of the ceiling as a flat surface, but what if it went on forever? Wouldn't it meet Mrs. Carlson's ceiling if it went on forever? they would hit, right? Now, if you think about Mrs. Cope's ceiling downstairs,
No.
no.
That's
Yeah, that would be, again, parallel planes, right? So a plane, this is something you probably need to know now. You name a plane with any 3 points that are not in the same line. That should be easy to do here. Any 3 points that are not in the same line. So can you tell me 3 points not in the same line, Andrew? U, T, and S. Very good. So, smarter. U, T, and S. We wrote actually those 3 points in number 1. See, but this time, when we write U, T, and S, there's no comma. Now this makes a little bit of a difference. Because to me, those look like the same 3 points we used in number 1. The difference is, in number 1, we put a comma in between representing 3 separate points. But in number 3, we named a plane using 3 points on the plane, and there's no symbol. Okay? And that's it. Plane UTS. How about a line segment? Dante, can you name a line segment for me?
R and Q.
R and Q. Didn't we already use R and Q for a line? So what Dante's saying when we say R and Q is this. Don't go past R and Q. You stop at R and Q. And now we're representing that blue part that's between the 2 points, Q to R, or R to Q. And Dante, like a diameter, or a radius, we put the segment symbol above it, which is? It's just, okay, yeah, it's a line, but it doesn't go on forever. It's like, let's call it a bar. No arrows on the end, R and Q. Can you spot the other one? Chris, can you tell me the other segment?
P and Q.
P and Q, and very good. Remember, we used that as a line before, but now we're using it as this, as just part of the line. That's a segment, right? The definition is part of a line, part of a straight path. It does not go on forever in both directions. We know it has 2 endpoints. So PQ or QP, and Chris, the symbol?
A line that ends.
Very good. A line that ends, or a bar. And again, in number 2, we used line PQ. Now we're talking about segment PQ. And those are a little different. Right? All right, finally, number 5 says to name 2 rays. Can you, while I erase, can you read me the definition of a ray? What are we on, page 5 or 6 now? Rebecca?
A line with a start point but no end point.
A line that has a starting point, but no end point. Meaning, I think, it goes on forever in how many directions?
1.
One direction. So Rebecca, can you name a ray for me?
Q.
Q. All right, so when she says Q, we start right here. And what point do you want to go through? Because it's got to start at one point but go through another. Okay, she said Q through P, and this is what she just described right there. Start at Q and go through P. So when I write my letters QP and I put the ray symbol above it, what do you think the ray symbol looks like, Rebecca? Rebecca? A line with 1 arrow. Very good. And since we started at Q and went through P, my letters go QP and the line goes through P. There's got to be another one up there though. Scott, can you pick out a different ray?
Q through R.
Q through R. Very good. We've got a different starting, I should say, we've got the same starting point, but we've got a different end point. Q through R. So we've got that starting point of Q. We have it going on forever through R. Okay? Out of curiosity, was anybody thinking P through Q? Would this be different? Starting at P and going through Q, is that a different ray? Is that different? Yes. It is definitely different. Because before we started at Q and went through P, and this one we started at P and went through Q. Those are going in different directions. I think there's another one up here. How about starting at R and going through Q? Is that a different ray? See the 4 colors? There's 4 different rays up there that we can name. Okay? So those are our major topics for the first set. Let's look at the second set. Notice how the picture is going to change on us. Let's move down a little bit on our page and let's name some angles this time. This should be easy as lesson 8.2 refers to angles. Oop, missed it. All right, name an acute angle. To name an angle like this, we have to name the 3 points we're going to connect. Can anybody spot an acute angle? Austin?
G, C, and
G, C, and what?
D.
Okay, I like part of what you said. I like the 3 letters, but we have to play connect the dots. So if you're going to use G, C, and B, we have to say it in an order that connects. In other words, start with C,
C,
G, B. Very good. And now that Austin connected the dots, now we can see this acute angle. So how do we write it? We write angle C, G, B. Earlier we wrote 3 letters without a symbol. And what was that? What's
T,
what problem was it? What concept?
Name 3 points.
Okay, no, not 3 separate points, a plane. When you name a plane, it's 3 points. No symbol. When you name an angle like this, we are naming the 3 points that connect. We call C and B points on the rays. This right here, G, is called a vertex. Vertex means it's where 2 rays meet to form an angle. Okay, name a right angle. By the way, first, number 6, is there more acute angles? Is that the only one? No, there's a ton of them, right? That's just one that we found. You could have went with FGE, EGD, DGC, BGA. There's a lot of them. Andrew, how about a right angle?
T, G, A.
Let's follow his line. Ready? D, G, A. Did he hit a right angle? Perfect. Angle D, G, A. That's the same angle as AGD. It's the same connect the dots, if you will. We know right angles have to add up to 90 degrees. Or not add up to, but they are 90 degrees. How about an obtuse angle? Obtuse. Alex? EGA. Very good. Again, connect those dots. E to G to A. Perfect. He hits an obtuse angle, which reminds me, the O in obtuse, I always think of over. It's over 90 degrees. Kind of like a cute angle is, oh, it's such a cute little triangle. Such a cute little angle. Really small, right? Like a cute little puppy. Number 9, name the straight angle. I think there's only one up there. The straight angle. Nick? FGA, very good. FGA. Looks like a line, doesn't it? But because it has a vertex, it measures 180 degrees. FGA. Okay. What symbol did I put in front of all my angles? Looks like a left-hand symbol, doesn't it? That's the angle symbol. So we have to use our symbols to correctly name points. Just like when we measured perimeter and circumference, we had to label at the end, miles, feet, inches. Now we have to label with, okay, what's the ray symbol, or the segment symbol, or the line symbol, or the angle symbol. Very important. Okay? That's a good review of a lot of things you guys already know or learned about. These would be some new things I think you wrote down in your booklets. So we need to make sure that when we look at numbers 10, 11, 12, and 13, even though you define them, let's see if we understood what we were defining. All right? I'm really going to need the definition for number 10, a supplementary angle. So in our booklets, page 14, what's supplementary? Go ahead, Gabby.
Two angles which have a sum that measures 180.
Okay, two angles. Let me put it this way. Two angles who has a sum of 180 degrees. Gabby, what does sum mean? When you subtract those two angles?
When you add.
Okay, so what we're looking for is two angles that when you add them together, they give you 180 degrees. That's what supplementary means. So a picture of that would be two angles that when you put them together make a straight line. Andrew, you got an example? Okay, let's start with BDE right here. I like that one so far. That's one angle. And notice how it says name a pair. Supplementary angles are two. Andrew gave us the first one. Angle BDE. And what's the other angle that's going to make a straight line with that one? Scott?
AD.
Not ADE. Is that what you said, ADE?
ADB.
Nope, not ADB. See, if you did ADB, if you did this one right here, you would end up with 180 degrees or 90. What do those two together give you? 180 or 90? They give you a straight line or a right angle. What do they give us?
Oh, it should be ABC.
They give you a right angle. I think that's actually an example of number 13, complementary. So let's back up here. We don't want them to add up to equal 90. We want them to add up to equal 180. So what's the angle that's going to give us the other part?
ADC.
What is it?
ADC.
Nope. Those don't connect. Andrew?
BDC.
Very good. Let's follow this. See how we ended here? Let's start here. And now when we do this angle, which is BDC, what do those two add up to together? What do they make? What does this angle right here represent? From here to here, and then to here. What's that give you? Alex? It gives you a 180 degree straight angle. Okay? There's another example. We don't have to write another one down, but look right here. 60 plus 120, I should say 60 plus 20. That is 180. So M, R, N, and N, R, Q, that's actually another example. Okay? There's a couple more there, but we'll leave it at that. Let's look for adjacent angles. There's a bunch of these all over too. The definition's on page 11 of your, page 12 of your booklet. Can you read the definition for us? Alex?
Angles in the same plane that have common vertex on a common side.
Angles in the same plane that have a common vertex and a common, did you say side? Yes, side or ray. In other words, adjacent, the way I always remember this is we find two angles that are side by side. Okay? Mrs. Holly's room and mine are adjacent. They are side by side. I wish she was here this morning because if I knocked on her wall, she'd probably knock back. Now, she's not there, but you know, we share a wall. So we're adjacent. What two angles can you spot that are adjacent? There's a bunch up here. Gabby?
ADB.
Okay, let's start here. ADB. I like that one. That's one angle. So let's write that one down. Angle ADB. And what angle is side by side with that one, Gabby? What's right next to it?
BDE.
BDE. That would work. Are these two side by side? Do they share a common ray? let's see. Is this right here sharing a side?
Yes.
Yeah, that means they're adjacent. They're side by side. I can pick out a lot of them. Check out this one. MRP and PRQ. Now we just talked a second ago about how those are called supplementary because they add up to 90, I should say they add up to 180 degrees. But guys, if two angles are supplementary or complementary, they're also adjacent. They're side by side. Look next to you. Who's next to you?
Alex.
You're
Invisible.
you're adjacent to them basically. If you slid your desks together, you would share part of that desk. They are side by side. Okay? Number 12. All right, we're on page 11, vertical angles. Anybody got the definition for us? Nick, vertical angles. What are we looking for when we talk about vertical?
A pair of opposite congruents that form intersecting
Formed by intersecting lines. So, first thing I want to do, there's two pictures up here. Which one shows intersecting lines? The one on the left or the one on the right? Intersecting lines. Gabby? The one on the left. Okay, so we're right here. These are intersecting lines. Do you see two lines? I should say, do you see two angles that are equal? Go ahead, Nick.
angle PRM and QRM.
Okay, so when you look at PRM, that's 20 degrees. And when you look at the other one that is, it says opposite from it, NRQ, it is also 20 degrees. So when you have two lines that intersect, you have what's called vertical angles. So here's two of them, NRQ and angle MRP. Did anybody spot a different pair? Andrew?
MRN and PRQ.
Very good. You can see them right here. MRN and PRQ. Opposite angles are congruent when you have intersecting lines. Those are called vertical angles. They are opposite each other. And finally, number 13. It sounds a lot like number 10, supplementary. But supplementary added up to 180 degrees. On page 13, Dante, what does what does complementary mean?
Two angles whose measures add up to 90 degrees.
Measures add up to 90. Very good. So now we're looking for two angles that when you put them together equal 90 degrees. And what two do you see? Andrew? If we start with ADB, this angle right here, so we've got angle ADB, and what angle did he say was going to add to it? Well, BDE. And angle BDE. And if you look at those together, actually you could add those together, 65 and 25 is, well, you guessed it, it's 90. It forms a right angle. That's what complementary means. And if you ever confuse complementary and supplementary because they look so similar, when you count, what comes first, 90 or 180? What comes first? 90. When you say your alphabets, what comes first, C or S? C. So complementary comes first, it's 90 degrees. Supplementary is 180. All right. And finally, our last few questions. Some of these deal with new terms, and some of them deal with some old terms. We've got 4 examples of lines that we need to identify which is which. And the first one is your brand new one. Number 14 asks us for a pair of skew lines. And I see skew in your booklet on page 18. Gabby, what's skew lines? Page 18 in your booklet.
Lines that lie in different planes that are neither parallel nor intersecting.
Very good. Skew lines, I think is what's really important to remember is they don't meet. They're in different planes. And when I think of planes, honestly, I think of planes in the sky. You ever seen a jet stream in the sky? Have you ever seen a jet stream that crosses another jet stream in the sky, like two of those white lines? Do you think if those lines were in the same spot, the planes would crash? Or do you think they'd miss completely? Really? No. Those are probably skew lines. Because even though when you see them, they look like they cross, you know one is in front of the other. Okay? It's kind of like this. This side, ML, this line right here, is going up and down. AB is basically going front to back. So even though they look like they might meet, we know they're not going to. They're kind of running side by side, but look, one's up and down and one's front to back, so they're not parallel either. So our skew lines are ML and AB. All right? You could probably spot them here on a box of Kleenexes. These three-dimensional shapes are really good for these. Take this side that goes up and down and this one that goes front to back. You can tell those two aren't going to meet. So they're not intersecting, but would you call them perpendicular? No. They're not intersecting or perpendicular. Speaking of perpendicular, number 15. Where do you find perpendicular lines? Andrew?
And then second one,
Well, name them. We have to name them.
R,
RS
S,
and TU. Now those are lines, right, Andrew? So when we write perpendicular, we have to write RS with what symbol above it? Very good. A line symbol has two arrows. And what did we say? TU. Very good. Number 16. Even though RS and TU are intersecting, they intersect in a special way, basically. They form a 90-degree angle. So which two just simply meet? Which two are intersecting? Gabby?
WX and ZY.
WX and ZY are intersecting. WX and ZY. Finally, parallel, just to name them. Alex? AB and ML are parallel. Parallel meaning they would never meet if they went on forever. Okay? Excellent. Well, let's stop here for just a moment.